Okay, so today's first presentation is the title of today's first presentation is a numerical investigation on the resistance characteristics of nature-inspired underwater vehicles, and the presenter is Dr. Onur Usta. Yes, please.
Thank you, Professor Beji. First of all, I would like to thank to the Professor Ahmet Dursun Alkan and GMO Shipmart Organizing Committee for this conference. I'm very proud of being a part of this active and hardworking team. Thanks for everything. Now I'm sharing my screen. Can you see my first slide?
Yes, there's no problem.
Okay. Again, hello everyone. Welcome to my presentation. My name is Onur Usta. I have been working as an assistant professor for 2 years in Turkish Naval Academy, National Defense University in Turkey. Before that, I was working at Istanbul Technical University, where I completed my PhD. My field of study is ship hydrodynamics. I have been studying on numerical and experimental modeling of cavitation and cavitation erosion, uncertainty assessments of engineering experiments, vortex-induced vibrations, and ship resistance. Today, I'm gonna present you a study about numerical investigation on the resistance characteristics of nature-inspired underwater vehicles. Here is my outlines. First of all, I will start with the objectives. Then I will pass to the introduction part. After that, I will tell you about flow simulations and resistance predictions of DARPA UV model. You know, DARPA is a benchmark submarine model. After that, I will mention CFD simulations of boxfish-inspired UV models. Then I will share my results and discussions. Considering the history, it is seen that the development of the submarine was influenced by the geometric characteristics and swimming ability of the kinds of fish, whales, and sharks in the sea. From this point of view, this study aims to contribute to nature-inspired vehicles by presenting a newly generated forms inspired by geometry of a boxfish. The other aims are to show that resistance characteristics of UV forms can be predicted by CFD and to present resistance predictions of a benchmark UV form with numerical validation and verification. In addition, investigations of new generated UV forms, including resistance predictions with numerical verification. Nature offers unlimited potential in addition to being a home for people for millions of years, and people have developed a wide variety of technologies for themselves using the potential that the nature has given. Submarines are essential and specialized underwater vessels designed and built to perform underwater operations by Navy forces of many countries. Submarines have one of the widest ranges of types and capabilities of any vessel. Therefore, generating a new submarine hull form is a hot topic in marine engineering. Submarine is a very special and complicated engineering problem in terms of its strength, resistance, propulsion, and noise development. Here you see some examples from the history. On the left-hand side, you see the Ichthyneo submarine, which inspired by fish and replica of that submarine. And on the right-hand side, you see the world's first combat submarine, also the first American military submarine named Turtle. It was built in 1776, and the name of the submarine had given as Turtle because it was resembled two upper tortoise shells of equal size joined together. In this study, the source of inspiration for the generating UV forms is the boxfish, because there are many studies investigated aero and hydrodynamic properties of boxfish. Let me tell you a brief story. In the mid-1990s, Mercedes wanted to design a car, but not just any car, and though not just any design approach. Mercedes sought to design a vehicle that was advanced, aerodynamic, safe, efficient, and maneuverable. And to achieve all of these goals, Mercedes turned its gaze to the nature for inspiration. After much searching, the company looked to boxfish, which is a small tropical coral reef fish, as a model. So, one of the leading automotive companies in the world has designed a car inspired by the form of boxfish. The air friction coefficient of a boxfish is about 0.19, and the drag coefficient of the boxfish inspired car named Biocar is around 0.28, which is approximately 25% less than a normal car. So we decided to perform a study inspired by boxfish geometry. Here you see other studies which inspired by geometry of boxfish. All of these studies concluded that a boxfish geometry can be inspired for achieving a low drag vehicle design. Here you see CFD simulations of DARPA sub of AFF-1 submarine. We used that submarine as for the validation and verification our CFD simulations. After that, we carried out our boxfish inspired forms, simulations of the boxfish inspired forms using that conditions. We accepted our flow is steady and incompressible, and we solved the Reynolds average Navier-Stokes equations with the K-epsilon turbulence model. Main dimensions and 3D CAD model of the DARPA submarine model is seen. Here you see the validation. We carried out our simulations between 3.46 and 9 point in the range of 9.255 velocities, and you see the experimental and numerical results in the table, which is on the left hand side. Our difference is about 0.91, between 0.91 and 3.18. So we can say that we have a validation because our values are close to the experimental ones. After the validation study, we carried a verification study. I mean a mesh independence study. We carried out 3 different mesh sizes and 3 different velocities. And in that study, again, we ensured that the numerical stability is okay for our simulations. Here you see the boxfish forms from the literature and our forms, which are dark blue. We inspired from these geometries and generate our geometry. We generated 2 UV forms inspired from the geometries from the literature. Then, rescaling these forms, we generated new geometries. Here you see our geometries. rescaling process is carried out on X and Z coordinate. So we changed length and height. However, we kept the width of the forms the same. And therefore, from the shortest to the longest, all the forms used in the study have the same displacement to compare. The forms of the case 4 are generated having the same length with DARPA UA as well. Also, please note that all the displacements are equal to each other and also with DARPA model. CFD analysis of these forms are carried out with the same conditions as DARPA model. Here you see the some images from the CFD simulations. On the left-hand side, you see the boxfish-inspired UV in the computational domain and mesh structure around the UV form. And results. When the resistance product predictions of DARPA UV and boxfish-inspired forms 1 and 2 for case 4 geometries are compared, it is seen that the DARPA UV form has less resistance than boxfish-inspired geometries. We expected that result. And also it is seen that the geometry 2 of case 4 has the closest resistance values, that of DARPA model. When we compared numerically, we see that the difference between DARPA UV and boxfish form for the case 4 is between 5% and 14%. And at the right-hand side, you see the resistance comparisons of other boxfish forms. It can be concluded that the form 2 produces less resistance than form 1 according to the resistance predictions. Conclusions. This study shows that CFD can be used as a practicable and feasible tool in gaining insight into the various hydrodynamic problems and generating new designs inspired from the nature. Although the total resistance values of the newly generated boxfish-inspired submarine model are higher than a real submarine model, this study may bring a new perspective for new submarine forms to be developed inspired from the nature. And future works, much for feasible underwater vehicle designs can be generated inspired by the forms of different marine animals and various fish species in the future. And also, I'm planning to study on the underwater noise development as well in the future. Thanks for your attention. I can take your nice comments and questions now.
Okay, thank you. Dr. Usta. It was very good, I think, presentation, especially very attractive concerning the imitation of nature. I think that's very interesting. And this has been actually quite long time, but recently, I think with the development of computers, it is becoming more popular. And of course, we can do now much more because of the numerical tools, right? We can check the design in various shapes, etc. So that was good. Okay, is there any questions or comments?
Thank you. If I say something very limited, in a limited time, yeah, these kind of studies, I think, will result energy efficient solutions. I think everything we should observe, we should think, calculate, experiment on. Thank you for the presentation and this interesting topic.
You are welcome. Thank you very much, Professor Beja and Alkan. Thank you.
Thank you.
Okay.
Thank you.
If there is no other comments or questions, maybe we can just move on to the next presentation. Okay, our next presenter is Colonel Alparslan Tatlısuoğlu from the Turkish Navy. He's going to present. Actually, he's going to do two presentations, one after another. They are the part of his PhD thesis, and his first presentation is pressure measurements of an underwater detonation in sea. Okay, please go ahead.
Thank you, sir. This is Navy Captain Alparslan Tatlısuoğlu. I'm working in Turkish Navy Underwater Search and Rescue Command. Now I load my presentation. Here is my presentation. Blast pressure measurement of an underwater detonation in sea. In an underwater detonation, the formation of superheated and highly compressed gas bubble around the charge causes the tremendous pressure increase, which in turn gives rise to shock wave. The spherically propagating shock wave initially has a speed much faster than that of sound in water and steep from with a sharp peak pressure value well above the acoustic pressure levels, which decays in approximately exponential fashion. We try to conduct open sea detonation measurement. But firstly, I try to explain the underwater explosion area. The explosive, chemically unstable substance is triggered into a chemical reaction which results in the explosion. The unstable substance is converted into a stable gas at a very high temperature, approximately 3000 Celsius, and pressure 50,000 atmosphere. Almost instantaneous rise of pressure to a peak value in the superheated gas generates a compression wave with a steep wall-like front end exponentially decaying back, propagating radially. This is called the shock wave, and it is the most destructive one amongst a series of pulses generated by an underwater explosions. Here is the general formula describing the size of shock wave. It was first declared by Dr. Robert Cole more than 60 years ago. We try to set underwater explosion field measurements, and underwater pressure measurements were carried out during a planned open sea underwater detonation. Time histories of pressure charges in water were recorded at 8 stations placed at different locations. Evaluating of measurements and use of peak pressure values for redetermining the coefficients of the empirical power law approximation. An underwater detonation with 8 pressure gauges mounted on a suspended steel frame in the seawater was carried out. A cylindrical explosive of 25 kilogram TNT equivalent was detonated in the Sea of Marmara. The charge is under 18-meter depth. The time histories of issuing pressure variations were recorded by non-resonant high voltage output PCB series pressure sensors and L-shaped steel frame suspended by buoyant spheres was used to hold the pressure gauges at different positions as on the screen. Shock wave was measured. These values is the most important parameter for assessing the potential damage to a sea structure. Therefore, special attention is paid to this value and its prediction. Here are the graphics presenting the major peak pressure values and the corresponding distance from the charge for all the gauges. Time is defined in milliseconds. Pressure is defined in megapascals. Gauge 2 and 6. Gauge 8 and 3. Gauge 7 and 4. The peak or maximum pressure and decay time theta would obviously depend on the quantity of charge and the distance from this charge and which the observation is done. Our aim is to redefine tuning parameters which are screened on the screen A and B. Using the measured data given in table before, the coefficients in equation are determined by the method of least squares. Following the usual approach, first we take the natural logarithm of equation. Then we obtain x and y datas. After that, we set the x and y datas. We obtain linearization and we got new tuning parameters. We can see these values are slightly different from the solutions obtained from the usual approach given by Dr. Cole. Visually, only minor differences can be observed. However, comparisons with measurements for each pair revealed clearly that the error minimization done by direct use of power function results in the least errors for the data point used. Here are the results: direct, measured, logarithmic, and standard. Conclusion: blast pressure measurement records of controlled underwater explosion in the sea are conducted. All 8 gauges were exposed to shock wave just in about 1.8 milliseconds. Since actual sea trials are rare, these records are expected to be quite useful for testing the relevant numerical simulations. Parameters of the semi-empirical maximum pressure formula are determined by use of field data via 2 different formulations of the error function. Calculated coefficients show slight variation depending on the specific error function, but agree fairly well with the generally accepted values. This agreement serves as a further assurance for the accuracy of measurements. Thank you. I'm ready to answer your questions and comments.
Okay, thank you, Colonel Tatlıoğlu. I think this was also important because just like the first presentation, this also has own importance because the field measurements, especially for underwater detonations, as far as I know, are very rare, and most of the times they are not revealed because of the confidence reasons. They don't give away the measured data. This was one of the really rare instances, let's say, that we are able to confirm and reveal the actual field data for the underwater blast measurement. Thank you. Okay, are there any questions?
I have just a comment.
Please.
As far as I know, thank you for your presentation, by the way. As far as I know, underwater explosion is a very hot topic, especially in the military applications. I'm very excited about to see your future studies. I just want to comment on that. Thank you.
Thank you very much.
Dear Chairman, I will give a comment. Thank you. Underwater acoustics in the still water and also in waves, I think both are interesting. For the experimental studies, of course, explosions and so on, you need larger area and security and so on. You should you should prepare the experimental facility. But our facilities in Istanbul Technical University and Yıldız Technical University, we have a wave tank. I hope you can set an experimental setup and investigate the acoustics in waves.
Sir, it is my honor to have a chance to do experiments with that facility. I hope I try to do my best because there are more area to investigate and analyze. I know that. I try my best. Thank you.
Yes, thank you for all these comments. And any more? Is there anything more? No. Okay. Now I think we can move to the next presentation. It is a continuation of the present work. Actually, it is about the numerical simulations of shock wave effects on a ship-like form. Now again, our presenter is Colonel Tatlısuoğlu. Yes.
Thank you very much, sir. I am Alparslan Tatlısuoğlu. I am Navy captain. I work in Turkish Navy Underwater Search and Rescue Command. It's my honor to present this topic. Numerical simulation of shockwave effects on ship-like form. Firstly, I want to show you footage from USS Gerald R. Ford's first explosive event of full ship shock trials. It was conducted on Atlantic Ocean on June 18th, 2021.
We don't see anything on the screen.
Yes, can you share the screen, please?
Sorry.
Yes, it's okay.
Okay now.
numerical simulation of shockwave effects on ship-like form. Here is content. Powerful underwater blasts that threaten the combat survivability of the Navy ships or submarines are a major security concern. Impact of a shock wave on a sea vessel may cause severe structural and equipment damage, besides personal injuries and casualties. Therefore, naval ships must be shock hardened as much as possible to ensure combat survivability for both personnel and equipment. The most reliable way of testing a ship for survivability is to conduct shock trials. However, with extensive planning and coordination, such a trial may take a year or more. Furthermore, environmental lawsuits can cause the delay or even cancellation of the trials. And an actual trial involving underwater explosion can destroy the tested military vessel completely. For all these reasons, realistic combat testing of military vessels is quite difficult. On the other hand, predicting structural response of a submerged or surface vessel to underwater shock waves is a study subject, whose outcome is much sought by naval engineers. To this end, numerical simulations offer an alternative for studying structural responses and assessing effects of underwater blasts. So we try to analyze shock effects on ship-like form with 3 numerical simulations. An ALAE code is used for the simulations of shock wave effects on a ship-like structure. Structural deformations observed from the hydro code simulations are correlated with the corresponding TSF values for formulating a simple expression to estimate the extent of damage quantitatively. Basically, linear dependency of the maximum permanent deformation of TSF, though observed for limited data, established as a confidence on the reliability of TSF as a simple criterion estimating the extent of damage due to underwater blast. We try to analyze the structural response to index. Numerical simulations using the software Elestina require the specifications of definite components, so we model explosive, fluid, air, and structure. The ship geometry is modeled as a box-like barge structure of length 42 meters and beam 8.75 meters with appropriate longitude and transverse structural components and 2 bulkheads. The total weight of the structure is represented as 3 lumped masses of 370 tons, evenly placed along the keel line, ensuring that the center of gravity corresponded to amidships. Shell plating is specified as 0.2% sea-hardened steel of 7 mm thickness. The structural steel parameters used in these simulations correspond to the steel commercially called DH36. We know that mechanical and thermomechanical tests performed on DH36. A first simulation data are on screen. We use 500 kilogram explosive TNT equivalent. The second simulation is similar to first simulations, just different of weights of explosive. The second simulation, we use 1000 kilogram TNT equivalent. The third simulations are similar to second simulations, but the location of the explosive is just underneath the ship. So the theta is equal 1. Sinus theta equal 1. In order to observe certain location on the ship hull, 8 specific nodes on the bottom of the model were selected. Here are the nodes. At these 8 nodes, simulating data were recorded using the database history node command. This particular feature is crucial in obtaining the structural displacement, velocities, and accelerations at selected locations. We use 5 different kinds of beam elements. Sorry. 3 different sizes of stiffness, transverse elements, fine steel plates, 5 millimeter and 7 millimeter thickness. These are used as shell elements covering the box-like form. Every simulation took approximately 10 days. Here you can see shockwave effect on the ship-like form in the third simulation. Here are the data of all 3 simulations. Here are the displacements of first simulation, velocity of first simulation, accelerations of first simulation, displacements of second simulation, velocities of second simulation, accelerations of second simulation, displacements of third simulation, velocities of third simulation, accelerations of third simulations. The maximum displacement values as average for all 8 nodes for simulations 1, 2, and 3 are found to be approximately 37.8 centimeter 56.6 centimeter and 90.8 centimeters, respectively. The computed deformation for simulation 3 is obviously too large for the material to withstand without breaking, hence it should be viewed with caution. Effects of a 3D underwater explosion on a box-like structure representing a ship beam are investigated through numerical simulations by employing the software LS-Line with the ALE approach. 3 different simulations are performed to explore the effects of various in KSF. The second simulation, designed for KSF almost equal with 1, represented a case for which the field measurements were available through not open to general use. With the use of limited simulation data, a linear relation between the maximum deformation and the corresponding KSF values is established. So, 3 different simulations are performed to explore the effects of variations in KSF. With the use of limited simulating data, a linear relation between the maximum deformation and the corresponding KSF values is established. Considering the calculated kickoff velocities for KSF equal 1 series, but for KSF larger than 1, fatal damage to ship-like structures appears certain. Thank you. I'm ready to answer your questions and comments.
Thank you also. Maybe we should clarify a little about this KSF. I didn't notice if you have defined it there, but KSF is a measure of actual damage established through the years. So it means it is related to the explosive mass and the distance and the angle of the explosion taking place with respect to the keel of the ship. So it seems, I mean, from there, if I may contribute to the conclusions, it seems that KSF is a good measure to estimate the damage. At least it can tell us that if there will be a serious damage or even a devastating one, from the beginning we can make an estimate as to the extent of the damage. I just want to clarify this as an advisor to Colonel Tatlısuoğlu in this work. But we can take, of course, any other questions and comments.
Yes, thank you.
Thank you
Thank
very
you, sir.
much. Thank you.
Thank you.
Okay. If not, then now I'm going to pass it over to Dr. Usta from now on to do the presentations or to introduce the speakers. We may share the work maybe.
Okay, the next presentation will become from Oğuzhan Kırıkbaş. The title of the presentation is A Review of the Rules and Regulations on Submersible Maneuvering. Yes, please, Mr. Kırıkbaş. Your microphone is off, Oğuzhan. Microphone. Mr. Kirkbash,
Can
yes,
you
now,
hear me
okay.
now?
Yes, okay, thank you.
Welcome everyone. Today I will present you my study titled A Review of Rules and Regulations on Submersible Maneuvering. Here is the contents of my presentation, as you can see on the screen. As you may know, safety is the major consideration for all sorts of maritime activities. Assuring a proof of safety regarding platform and its main equipment throughout their life cycle is the fundamental mission of the classification societies. In order to achieve this duty, classification societies get involved the milestone topics of the ship life cycle at different extents by their established rules. These rules are mainly focused on strength, reliability, and redundancy of the vehicle and its critical systems, and they generally draw a frame of minimum requirements. For instance, nearly all societies necessitates a proof of midsection strength of the ship throughout investigation of the sizing of structural components. By doing this, they get involved the ship's life cycle directly at a very early stage or at a very early design stage. Other topics such as maneuvering may attract the society's attention indirectly. The rules regarding such topics are only considered by means of its effects on the above mentioned notions, reliability, strength, and redundancy of the final product. Until last few decades, the primary area of operation of the classification societies is the classification of ships, which involved merchant activities. Naval vessels of auxiliary class are the first one, which have been classified according to the rules of a society. However, their classification is generally based on the merchant rules due to the similarity of these ships between their merchant counterparts. The outcome of this contact between societies and the navies are the realization of mutual benefit of the extending classification procedures to the all platforms, including the combatants. This necessitates the establishment of class categories, special type of rules and procedures for each type of vessel. Nowadays, nearly all new buildings for the surface fleet of the Navy is subject to classification procedure of a society. Since the pioneer and major end user of the underwater technologies are mostly the navies, this growing potential about the surface fleet generate the expectation that this trend will eventually find its counterpart also for the subsurface fleet, mainly in the countries which have design ability of such vessel and systems. ABS and Germanische Lloyd are the first classification societies that meet this expectation. It's shown in screen and in the table that the countries which are capable of designing naval submarines and have underwater class rules. Out of 9 societies from 12 members of Ajax have rules regarding submersible vehicles. Here are some regulations about submersibles which are related to maneuvering. Classification societies also have to undertake the regulations of flag states in their rules. For instance, U.S. Coast Guard, empowered by the U.S. Congress to supervise all the passenger carrying activities in the U.S. territorial waters, covering also the touristic activities performed with submersibles. As a result, the rules regarding passenger carrying passenger carrying submersibles of ABS take their current flow according to the requirements imposed by US Coast Guard by using the above-mentioned authorization. In general, these regulations do not contain any specific articles about maneuvering, which can be directly used as a guideline or imposed classification societies to establish rules on maneuvering of submersibles. Their fundamental role is enforcing the maneuvering tests and trials to be performed. Furthermore, they do not apply to the naval or state-owned platforms. Here, the countries which are operated naval submarines are seeking for a regulation which can be used as SOLAS. So a naval submarine code is generated. The approach of naval submarine code can be divided into three categories, like loads to be considered, submarine maneuvering propulsion system capability, and operational. As a result of being a goal-based code, analyzing these regulations reveal the results that there is again no direct restrictions on the maneuvering characteristics of the submarines, but some valuable higher level requirements. To ensure the safety of this type of vessels, as I mentioned earlier, SOLAS for merchant fleet, and close this regulatory loophole, Naval Submarine Code developed and published as a NATO ANEP document, ANEP 102. The overall aim of the code is to provide an international accepted baseline against which a submarine can be demonstrated to be safe to operate throughout the regulations, covering the entire phases of the submarine life cycle to design to manufacture and maintenance. It also addressed all the risk which can be encountered during in the life cycle of the vehicle, and its scope is only restricted with the peacetime operations. From the Naval Submarine Code, it's still possible to get insight as a guideline for developing classification rules on maneuvering. For instance, in order to meet the requirement of having operating envelopes and maneuvering limitation diagrams, a large amount of calculations as well as tests and trials must be performed during the design phase and at the end of the construction. Moreover, dynamic stability of the vehicle must be investigated with no doubt and proven to be adequate according to some sort of criteria. The current status of the rules on maneuvering of the IACS members can be categorized as you seen on the screen. Not all of the classification societies under consideration publish specific rules in each category. Some of them choose to cover a secondary category by applying the rules of another primary category to the former one. I categorized the rules in three main topics, as you can see. The rules which can be proved by investigating design documentation and drawings. The rules which can be shown by performing tests and trials, and calculations and simulations. Because different classification societies use different wording, it's not possible to compare them word by word, but I try to compare the enlarged meaning of the text. These are the rules which can be proved by design documentation. And these are the rules which can be proved by tests and trials.
You have 5 minutes left.
Okay. The reason for these two categories, there is much analogy between classification societies because the minimum required design documentation drawings are well defined, and naturally after completion of the construction, tests and trials must be performed. So the varsity show itself in terms of rules, which requirements have to be proven with calculations and simulations. And these rules, and this part is also where the most regulations of the Naval Submarine Code is covered. Since maneuvering is a topic which is not well understood as structural integrity, the societies prefer to establish rules regarding this topic in general terms, covering several aspects of the design at once. This requires performing of several calculations and simulations for proof. The rules do not contain any specific requirements expressed numerically, rather than the requirements are generally in the form of, under a defined condition, the vessel or systems may have the ability to meet the specific requirement. Here, the dynamic stability is the one of the major topics which can be proved in submersible design. And that's directly related with the safety. However, the maneuvering and the dynamic stability are somewhat conflicting concepts. Here I recommend some rules for the classification societies, which can be found in the open literature. Here, as you can see on the screen, this is the well-known concept of vertical stability index. In order to perform depth control with minimum error and minimum wear and tear on both the operating personnel and equipment, the vessel must be at least vertically stable. Classification societies may provide some empirical formulas for estimating the unknowns, estimating the maneuvering derivatives in this formula for the designers. Alternatively, they may encourage the use of CFD simulations for this purpose. Another aspect of the vertical stability is the damping ratio. Because the characteristic speed is low for the tourist submarines and unmanned submersibles, hydrostatic restoring moment is dominant compared to the hydrodynamic one. Because of that, there may not necessary for setting a criteria for damping ratio for this type of vessels, but characteristic speed is high for the naval submarines, and there must be a damping ratio criteria at least 0.7 IS for the naval submarines, and this can be published and as a rule. The last topic will be discussed is the rising stability. Operational safety requirements of classification societies and other regulatory bodies enforce the designers to take precautions for the case of losing surfacing ability. These precautions consist of decreasing total weight or increasing the buoyancy. The weight reduction can be made dropping ballast as used in the tourist submarines. Increasing buoyancy can be possible via blowing ballast tanks by using emergency blowing equipment, pressurized air or solid rocket engines, etc. Both of these cause the boat rising rapidly with an angle of attack, and its sail pointing upwards.
Sorry for the interruption, but I think you should be a little bit faster and to wrap it up.
Okay. Instabilities caused by this complex flow must be compensated by static stability of the submarine in the vertical plane, but the static stability is vanished when surfacing, especially emergency surfacing. So there must be a criteria for the surfacing speed, and Watt in 2001 proposed a vertical velocity threshold, which in case of exceeding will cause the loss of vertical stability, and this can be used as a rule. And in conclusion, the using of multiple underwater vehicles together with a mother submarine is a developing concept, and this brings a risk of collusion. And also in parallel, the worldwide applications, utilization of submersibles also gained popularity in Turkey. Moreover, Turkey has the intention of performing the design and integration of a naval submarine by solely relying on its own sources, including classification phase, for the sake of confidentiality. These facts, while considered together, led to the result that Turkish Lloyd have to build a solid knowledge in submersible classification and gain ability to guide the designers with its rules. So authors acknowledge the contribution of Dr. Mehmet Ali Baykal for the proposal regarding the subject of this work. Thank you for listening me. If you have any questions, I will appreciate to answer.
Yes, thank you very much for your detailed presentation. Submersible maneuvering is a very hot topic, especially in military applications, and I'm very excited to see your future studies. And now we can take questions or comments from the audience. Does anybody have questions or comments?
Thank you for your contribution. No comment.
No comment. Okay, then we can move with the next presentation. The next presentation will come from Buğra Uğur Yazıcı. The title is Hydrodynamic Optimization of a Submarine Forebody Using Bezier Curve and Generic Algorithms. Yes, please, Buğra Uğur Yazıcı.
Thank you very much. Now I can't share my screen because Mr. Kırkbaş's screen is sharing.
Okay.
Mr. Kırkbaş, would you please close your session?
Okay. Sorry.
Yes. Okay, we see your screen.
Okay. Okay.
Thank you.
Good afternoon to all participants. This is Buğra Uğur Yazıcı speaking. First of all, I will thank you to organizing committee for their efforts and contributions for this valuable congress. I'm a senior submarine design engineer at STM Savunma Teknolojileri ve Mühendislik AŞ, working on the mid-life upgrade project of Preveze-class submarines of Turkish Navy. In addition to performing advanced engineering calculations, I am responsible for the structural integrity and layout optimization of various systems. As someone who thinks collaboration between academia and industry is the pillar of the sustainable future, I hold a master's degree in naval architecture and marine engineering. I am currently pursuing an academic career with a PhD in the same field at Istanbul Technical University. My research area primarily focuses on the optimization of hydrodynamic and maneuvering characteristics of submarine hull forms. Within this field, I am planning to specialize in the development of design environment that integrates different disciplines, including parametric design, optimization algorithms, reduced order modeling, and computational fluid dynamics. This presentation consists of 7 sections. And in the introduction section, brief information about submarine bow forms and the geometry will be presented. General outlook of the methodology is to explain developed platform for the optimization process. CFD method and the geometric definitions will be presented in the 3rd section. The formation of the geometry using Bezier curves will be explained shortly. Optimization process using deformed curves will be detailed, and finally, results and the conclusions will be shared. This submarine hull form can be divided into 3 main regions: forebody, parallel middle body, and the aft body. In this presentation, forebody of a submarine body will be of interest. The shape of the submarine forebody is one of the most important factors for low drag. Low drag means higher maximum speed and increased endurance, which means higher operational time for submarines. It is also associated with the positioning of acoustic sensors, torpedo tubes, and starting conditions for the flow around the hull. One of the main design criteria for the submarines is to ensure that the incoming laminar flow is transmitted along the submarine hull without being disturbed. In this way, it is aimed to prevent turbulent flow in the forepart where cylindrical sonar array is positioned, thus enabling the sonar to operate effectively. Even if blunt nose shape enabled designers to have more torpedo tubes, it was found that the blunt forebody shape resulting in extensive local adverse pressure gradient, and this becomes the basis for the circumfraction coefficient no longer decrease with an increase in flow velocity and remains constant after a critical velocity. This makes it possible for a blunt body of revolution to have 2 times more drag compared to a streamlined forebody. Bow form can also be associated with the stealthy characteristics of the submarines, since it has an important effect on the reflection properties of sonar waves that can be identified as target's echo strength. In the right-hand side, there are 2 different bow shapes of a submarine. Then these submarines are widely used in the navies outside. And the Elastic class is a very well example for the target echo strength wise design. And Virginia class is a streamlined design, and it has an elliptic bow. And Sorry class has also elliptic bow, but it has a different profile. In the present study, the forebody drag optimization of a DARPA sub of AFF1 geometry has been investigated. 3D model of the bare hull form can be seen on the upper right corner of the slide. First, geometric definition of DARPA sub of AFF1 form modeled by using SalomeCAD software. Then computational analysis has been carried out by open source CFD software, OpenFOAM. Results have been validated with the experimental data using a mesh dependency study. Later, mesh deformation study using Bezier curves has been done to create optimization variants using the DARPA sub of curve equations. Then an optimization study has been carried out to find optimum hull form in the given design space and constraints. Finally, optimized bow form was compared with the well-known elliptical head forms, forebody forms. In the capability of the optimization method has been evaluated. In this slide, the general outlook of the methodology platform will be presented. As you can see, Python is the core of the integration and process handling tasks. The whole platform is commenced with the Python code, and the design variables and the constraints are defined in the source code. Python code is also responsible for creating variants folders, integrating modules, and pass information between them. First of all, Python code initiates the optimization library, namely DApp, to have the parameters of the new variants. And these parameters then are sent to the curve deformation code, which is also natively written in Python and implementing Bezier curve-based deformation technique. Deformed and newly created bob form curve and other parts of the DARPA sub of AFF1 are returned then to the Salome CAD. After this step, the Salome CAD is activated in order to obtain parametric hull form, domain generation, patch naming, and exporting the domain with the hull geometry is done by Salome. And finally, exported domain, which is in STL format, is the input for CF mesh library. Before starting optimization process, boundary condition, initial conditions, and solver settings of OpenFOAM is saved and used as a template files. Necessary amendments on the files are done by Python source code. The overall geometry in open source documents are issued by DARPA for two sub-of models, namely DTRS model No 5470 and 5471, and these are identical. Therefore, DRTC model 5470 is implemented in the study. The axis symmetric hull has an overall length of 4.536 meters and maximum diameter of 0.508 millimeters. Both equation, parallel mid-body equation and after-body equations are given respectively in this slide. The direct analysis of a submarine form have been carried out with the state-of-art open source code, CFD code, OpenFOAM using run solver, simple form, which is a steady state and turbulent incompressible flow solver. SSTK omega turbulence model is applied to simulate turbulent flow around the submarine. Second order upwind scheme has been selected for the momentum and turbulence terms, and a simple algorithm for the velocity pressure interaction has been selected. Dimensions of the computational domain is shown on the left-hand side, and the one on the right shows the boundary conditions imposed on the domain. The left and right sides of the computational domain have been defined as the velocity inlet and pressure outlet respectively. DARPA sub of hull has been defined as no slip wall to impose kinematic boundary condition. The surrounding surfaces denoted as far fields in the right figure have been defined as a symmetric plane. For direct analysis, unstructural hexahedral elements have been created around the hull. OpenFOAM extension CF mesh has been utilized in the grid generation process. Cartesian mesh algorithm has been used to generate the control volumes, and thus the fully hexahedral mesh structure has been obtained. Unstructural mesh around the DARPA sub of hull is shown in the left-hand side figure, and the mesh size on the hull surface has been adjusted to keep Y plus values in an acceptable range. Average Y plus values of the submarine hull is around 4 for 3 meters per second velocity. After mesh dependency study, it can be seen in the table that the fine mesh around the hull is the most convenient mesh size, which is around 1 million cells. And in this study, a second order parametric Bezier curve is implemented. And to define what is a Bezier curve, this is a parametric curve used in the computer graphics and related fields. The curves, which are related to Bernstein polynomials, are named after a French engineer, Pierre Bezier, who used it in the late 60s for designing curves and the bodywork of Renault cars. The equation for the formulation quadratic Bezier curve formulation can be seen in the slide, and these B0, B1, and B2 are the points of the Bezier curve. For explaining the formation process clearly, initial forebody of DARPA sub-off is plotted using 10 control points. It's the upmost or uppermost of the plots. And in the same manner, a Bezier curve using exactly the same first and last point of Darpasabov and the middle point, which has the coordinate of 1 in x direction and 0.5 in y direction, is created also with 10 points. And as it can be observed with the blue dotted lines, x coordinates of the Bezier curve and initial Darpasabov forehead are not aligned with each other. Therefore, the first thing is to create a mapping function in order to make them aligned in the x coordinate system. After using a mapping system, one can easily observe that x coordinates of all points in the first and third plot are perfectly matched. The final step is to add delta values with respect to a y coordinates for the corresponding points of mapped Bezier curve to the initial curve. In this way, the position of the second control point of Bezier curve is changed and the curvature of forebody is altered, as it can be seen in the bottom of the plots. And after that, since the CFD simulations took a lot of time for the optimization process, in order not to create geometrically inappropriate designs after deformation, it is necessary to check the control points of the new deformed curve. In this way, it's prevented to obtain values larger than the breadth of the initial form, and these forms geometrically inappropriate because that concludes in manifold geometry whose any y values is less than 0. A function using Sobol algorithm has been created to determine the limits of the variable y to be used in the optimization algorithm. This function returns 0 if the curve is violated the geometrical constraints, and 1 if the curve is feasible. Curve control analysis was performed on a 100 by 100 even-spaced grid and presented in the right-hand side figure. Sobol algorithm is a space-filler figure, as you can see in the left-hand side. And by using this Sobol algorithm, it can be easily concluded that y values should lie between -1.6 and 0.05 so as to have feasible designs, as in the right-hand side of this presentation. And the optimization process, the open source DAP library has been utilized when creating an instance of a genetic algorithm in order for variant parameters to be meaningful, but bitwise mutation is blocked. Parameters for crossover probability and the mutation probability were taken as 1, and it's observed that when these parameters are relatively low, same variants created in the populations which are diminishing overall performance of the optimization process and increasing the total computational time. Selected algorithm is defined as NSGA2. In the NSGA2 algorithm, the population evolutionary strategy can be concluded as according to the fast non-dominating sorting strategy to determine each individual's non-dominated level. The total number of 15 generations have been created. Each consists of 10 individuals as population. Therefore, 150 variants created and analyzed in the optimization process. Coordinates of
Can you speed up, please?
Okay. The total drag of the optimized hull form, which is the 114th variant of the design, is the optimum one, and the design as it can be seen in the slide, is reduced as 7.32%. And on the left side, pressure distribution of the initial hull is the upper left-hand side, and the optimum hull lower can be found. And it can be noted that the negative pressure contours have abrupt change in and more in length for the initial hull as compared with the optimized hull. Pressure distribution on the forward section of the initial hull is changing rapidly. However, optimized hull has more smooth transition and pressure does not drop significantly in the nose section. Velocity distribution has the same trend when comparing the pressure of the forms. it can be easily observed that velocities are equal to inlet velocity reach out for the optimized hole in the middle section more than the initial one. On the right-hand side figure, Q criterion with vorticity contour is shown. Vorticities are dramatically reduced in a forebody section of the optimum hull as compared to the initial hull. And this figure shows the best individuals among the generations almost coincide with the optimal streamline shape that can be defined as Munesun suggests. And using elliptical form equation, Munesun find that optimum shapes for the resistance characteristics have value of NF around 1.15, as you can see in the red green dots in the plot. And the optimum form that has been found in this present study can be is shown as an orange line. Conclusions of this present study is the cubic Bezier curves can be implemented within the deformation phase. Adding extra control points to the deformer curve may increase the complexity of the process, and unfeasible type of generated variance may be observed. For constant parallel mid-body and off-body curves, parameterization of a four-body curve has been realized just using two parameters. Therefore, the complexity of the system is very low, which causes genetic algorithm to find best variance easily, even if unfeasible geometric constraints enforced to be used within the optimization loop. Genetic algorithm that implements an NSGA2 selection algorithm has been employed to find optimum four-body hull shape. Bitwise mutation and method of the algorithm is cancelled out to have design variables of newly generated hull forms to be restrained. In this way, consistent and robust design space have been obtained. 7.32% drag reduction has been achieved by the genetic algorithm, keeping the total four-body length and maximum hull diameter as constant and equal to DARPA SOBOP AFF1, and each simulation took almost 8.5 minutes with the presented core. Thank you very much for your attention. If you have any questions and comments, I would like to answer them.
Thank you very much, Mr. Yazıcı. Another very interesting topic and very interesting presentation. Thank you very much. And now we can take questions or comments.
I have a comment about the study, if you permit me to talk. Thank you for the presentation, Buğra. I have a comment about it. So there, as far as I can understand, there's a trade-off. This is a single constraint optimization, right? You take the total resistance as the integral variable here.
Yes.
Yeah. Okay. So I think a better study would also include. So there must be ship design is a process of trade-off. So if we are gaining something from somewhere, we have to be losing something from another place. So, for example, are we losing some seakeeping abilities or maneuvering abilities of the ship? A better study, I think, would include some seakeeping or maneuvering analysis of this of the original and the optimized forms. I mean, in my opinion, I can see that we are also losing some space, some displacement, right?
Yes.
Or so you may also think of keeping the displacement constant when optimizing your form.
You are 100% right, sir. And I have another work and study for implementing the multi-objective optimization, keeping into account the volume and prismatic coefficients and some other parameters that affects the overall performance of the submarine hull forms. But in this study, what I am trying to implement is to have a partially parametric design using just two variables, that is the coordinates of the Bezier curve. This is the main idea behind this study, but you are right. and I am trying to implement what you suggest in your comments.
Thank you. Thanks.
Thank you very much. Are there any questions or comments about the study?
Thank you very much. It was very impressive.
Thank you.
Thank you very much.
Okay, so I believe there are no more questions, and maybe we are just going to wrap up the session then. If there is nothing more, I mean, any comments or anything else? Nothing. Okay, so then thank you for all the participants, and we are just closing the session then. Yeah, have a good day. Thanks. Bye.
Let's pass to the other next session. Dr. Türkmen, are you ready for chairing this session? He's here. I have seen you. Sorry for
I'm
the
ready. Hello. Hi, everybody.
Can.
I think I'm the only chair at the moment.
Yeah. Hasan Ölmez, yeah, he had a family duty. Maybe he will come later. He will join us later. The time is very limited, so
Yes, I can start yeah, as soon as possible. Okay, then shall we start this new session 8-2, and then first paper is yours, is Professor Alkan's, and investigation of environmental effects of high-speed boats, which was also my favorite topic when I was your student.
I thank you very much. The time is limited, so I don't give any introduction. I should say that the number 60, my second presentation, we skip it. Why we skip it? Mr. Onur Karataş is out of city. I think we will present it and record and merge in the video file as a video file. So let's start my because it will be more impressive together with the industry. Number 60. Let's start my video. Presentation. Here is my presentation page. Can you see all?
Definitely.
All my page. Can you see?
Yes.
Let me start.
Your presentation, only presentation. Yes.
Presentation table, yeah. Pardon, screen. Investigation of environmental effects of high-speed boats. Of course, when you increase the speed at sea, you create many problems, but not for compulsory speed, not for emergency health services, patrol boats, so on. But especially for pleasure, if you increase the speed, what you encounter, I would like to show it. Here is my outlines of the presentation. With my colleagues, I'm proud of them. Dr. Onur Usta, Alpay Acar, and doctoral student Elisata Sayan. Alpay Acar also doctoral student. They are from Turkish Naval Academy of National Defense University. I worked with them more than 1 year there. We had already calculations, computations, what about the result of speed increase in terms of emissions, in terms of noise, vibration, so on. We studied. I will show some pictures, some slides from that study, but I will be speaking about a possible project which has also the social side. In the analysis, we have studied two hulls. Fritz Mahal and Catamaran. It is built in Turkey. We, thanks to the Ozata Shipyard's data sharing, we had also its trial and experimental results. Here are the model measures. We studied its experimental fluid dynamics and CFD results, as well as the Savitsky outputs. We studied its resistance with respect to fruit number, non-dimensional fruit number. Then we had this outputs, total resistance plus prime movers noise rating. As you see, with the fruit number, with the speed increase, you sharply have resistance increase. And I can say it is the same, roughly same. The noise vibrations on also getting terrible. As you know, all heavy fuel oil produces 3 times CO2. Light fuel oil 3.1. Diesel gas oil 3.2. This is the largest. I mean, about more than three times you produce CO2 for the environment. Less fuel, less environmental damage should be our targets. Using this well-known practical formula, we completed CO2 emissions from the speed 20 to 35. You see it is drastically, the gradient is getting high. This is your CO2 ratings. It is the larger wheel. I cut this picture. This was a yacht in the internet. The seller says that he's proud of its speed reached. He says it reaches more than 8 knots. I mean, they sell speeds maybe. Noise is also terrible. I have a voice here. I don't show the video because of copyright so on. How can I pass through this? I think I should speak. Pardon. To pass, I should go off from the screen sharing. I manage it. I hope. How can I find it? Yes, on the left screen. I prepared my left screen. There is music upper side of the in the air. I mean, people traveling, they are listening to music, but later noise for the underwater.
I don't think we are hearing.
No problem. Maybe you couldn't hear it. Maybe I couldn't arrange the sound transmission. Sorry. I mean, with the speed, there is a lot of noise. So the underwater animals use this instrument. This is the uniform they use. No, next one. So what about my results, conclusions? When hull speed increases, propulsion power, of course, increases in a sharp manner. Its trend depends on hull form and seaway conditions. So on, efficiency of propulsion system decreases. Air, land, sea, and marine environment will be more damaged in terms of emissions and other effects, particulate matter, so on. Except special vessel, water ambulance, petrol boats, security boats, these kind of vital or for the boats using for human services. We don't speak about that, but excessive speed and especially high speed for pleasure have to be discussed, studied, regulated, or ruled. As efficient activities for public awareness, this would be a project with researchers, NGOs, public authorities, all partners. Hope to see this environment always. I concluded my presentation. Thank you very, very much.
Thank you, Professor Alkan. That was very brief, I have to say, and I think we catch the normal time now. Yeah, we are open to questions.
Yeah.
Maybe one or two questions if we can get.
Sorry, was the ship you were working on, Professor Alkan, was it water jet or a propeller, conventional propeller?
It was a catamaran with screw propeller, classic propeller, not water jet.
I believe it was cavitating, right? I mean, when I see the results, it seems to be cavitating because it has high frequencies involved in it.
Do you ask me this figure?
Yes, yes.
Can you see this figure?
Yes.
This noise, yeah, has been calculated by Onur Usta. He is also in the list of our Zoom meeting. I think cavitation has not been considered.
Okay.
On the noise, the engines rating of the producer, I think, and engine manufacturers booklet has been used to show this.
Thank you.
Full scale measurements, experimental and full scale measurements would be of interest. Any question?
I have a question, brief question. The graph just you shows actually Savitsky method is still quite valid for high speed. I mean, it seems we don't need really so much computer power. Nowadays, most of us really doing lots of CFD, and then can we tell like maybe up to 1 knot, one foot number, 1.5 maybe, this Savitsky is not valid. Maybe, I don't know why, that area. Maybe this catamaran, due to catamaran, I mean, Savitsky's monohull method, isn't it? But after certain speed, it seems it's happy with the other curve. What happened between 0.5 to 0.2 maybe, fruit number? The Savitsky is not valid for catamaran. Can we say that?
Yeah, the Savitsky, the hulls are cylinders. I think our students also listening us. Narin tekneler vardı. The catamaran demi hulls are cylinders. With our team, we calculated roughly, I mean, for a roughly estimation and reference, we used Savitsky just to show how it is going. Of course, EFD and CFD, experimental and computational fluid dynamics results were our realistic references.
Yes.
You discuss it. Thank you. Yeah, we should.
May I just add some points, Dr. Türkmen? Up below, if we are below fruit number 1, we cannot rely on Savitsky even for monohulls. So that's probably the case. I mean, because when the fruit number is below 1, I think he did not consider it that much, because planing hulls are usually over than fruit number 1.
For the high speed, especially the planing hulls, University of Naples, Federico Due University is very famous on that. The day before yesterday in the tank in the experimental session, Professor Claudio Pensa and Fabio De Luca, they presented their experimental studies. Of course, there are very complicated hull forms, underwater hull forms of planing or high-speed vessels. Just a single estimation, it gives you rough results. Fruit number range, if we speak about that, it takes hours. Thank you.
Thank you very much. I think if there are further questions, maybe we can take later. It's better to move if everybody's agree. Thank you very much, Professor Alkan.
Thank you. Thank you very much.
We are moving to the next presentation by Dr. Savaş and Dr. Bilgili about environmental assessment of ship welding emissions. Maybe they can also give brief introduction to themselves. I think, yes, thank you. think you can. Dr. Savaş, are you presenting?
You're muted, Arif.
You're muted.
So sorry.
Okay, now we can hear you.
Yes, so sorry. I am Arif Savaş from Bandırma 17 University. I am talking about environmental assessment of shipbuilding emission. Contents is here: welding, welding fumes, welding gas, the harmful effect, and conclusion. What is the welding? Welding is the manufacturing method using to join metals together, usually on metal or thermoplastic materials. In shipping, welding is the most common method for joining in shippings. There are 80 different types of welding methods are used in shipbuilding sector. The most common three methods is here: arc welding, gas welding, and resistance welding. Arc welding is metal electrode and electric power supply is using. Gas welding is a metal joining process, and arc welding the most common method in shipbuilding and the other industry. Gas welding a metal-joining process where ends are heated and interferes with gas flames. Resistance welding, no extra materials, only pressure and pressure current using. Welding fumes. Welding is the one of most important welding methods in shipbuilding, but as a disadvantage, welding poses some heat issues for the welders as well as the environment assessment of detrimental gas and fumes emitted during welding is important not only for occupational safety and health, but for the environment. We can see the fumes with naked eyes because they are so small particles. They are divided into three groups: ultrafine, fine, and coarse. This is defined by size. Welding gas. In addition, during the welding process, not only invisible particles, but also very different gas species that are harmful the environment and human beings emerge. These usually include carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxide, and ozone. How we can use the defined? The content of the harmful gas and fumes generated during the welding process depend on various parameters. Its form depending on conditions such as electrode type, electrode material, welders, and welding methods. Some organizations, such as Occupational Safety and Health Administration, have published the exposure standards for various components in welding fumes and gas. In determining the limits to exposure during welding, it's made as basis that a worker works 8 hours in a day average. According to the table, no heat problems arise for the worker who is exposed to harmful and gas in this amount. But if they are exposed to more, these serious heat problems occur in a short or later time. For example, if arsenic exposed to more than 0.01 milligram divided by meter cube, it has negative effect for body. The harmful effect of welding gas and fume to human effects. It's estimated that approximately 3 million people currently working in different sectors and are exposed to welding fumes and gas. If various safety precautions are not taken, negative effects on human health arise. During the welding process, the environment must well be ventilated and the welder must have the necessary protective equipment. Some fumes and effect of the body. For example, chromium effect of the lung cancer and skin irritation. Copper, eye, nose, throat, and noise. Some gas is carbon monoxide heat, disease, muscular weakness. Nitrogen oxide, it occurs within arc, eyes, nose, throat. And organic vapors, for example, phosphine, eyes and reproductive system, kidneys, and other organs is negative effect. If they are not productive, the effect, the vapors. The harmful effect of welding gas and fume the environment. Some welding gas and fumes have negative effect on environment. Although heavy metals are normally a part of our world, they can enter human body throughout the human activities. There are 10 different main heavy metals in the list published by the World Health Organization (WHO). Some of these are lead and mercury, heavy metals which are formed as a result of human activities and thrown into environment harm the environment. For example, overloading the soil with heavy metals will cause soil pollution. As a result, the agriculture sector will be adversely affected. If they mix the water, it creates the water pollution. Conclusion: welding is one of the most important manufacturing methods in shipbuilding, but they have a negative effect. To avoid the various harmful effects of these gases and fumes, attention should be paid to exposure limits and the use of the protective equipment. In addition, it's possible to protect welders' health and environment by using robotic welding. Thank you for the attention. Do you have any question or comment?
Thank you very much, Dr. Savaş. That was 5 good 5 minutes precise presentation. Thank you very much for the good presentation. Yes, surface is open for the questions, comments to Dr. Savaş. For sure, we are always considering the ship as a source of emission, but the shipbuilding process is also a source of emissions, isn't it? And then when you do this study, do you have any data you have collected from the, I don't know, like some hospitals, like the people who suffer due to this, the harmful gas? Obviously, we know that might be really harmful, but we don't know the numbers. Do you have any plan, or you have already done?
In future article or in future study, it will be including workers, welding methods, welding equipments. In experimental, not only article, it's experimental study. Maybe it will next time.
Yeah.
Which welding workers.
Also, is it affect their performance? I know there have been study about the noise on human factor, like their performance. I don't know whether like using the protective equipment or some robotic equipment, how the human factor changed, like their maybe efficiency, it might be different also, as well as their health, obviously. It could be also interesting, like to hear in terms of their performance when they have a bit more healthy surroundings, especially some in the shipyards has been done this. They check the workers how when they protected from noise, how their performance has been improved. So why not the emission can change their performance? It could be also interesting to hear.
Very interesting equipments. Everything is including the emissions. Every condition is workers, physical situation in factory. Every in workers' ability is every factor is actually every factor affects of the emissions, because they are including different materials, alloy, copper, metal, aluminum, everything impacts of the emissions. So every component is important. So every condition is important. Is workers' speed, workers' material speed, material type, everything. Only not workers. Material is included.
Yeah, that's true. Okay, I'm wondering if there are any comments or any question. Maybe quite fast presentation, so you have some time.
I don't have enough time. I need to go abroad, go out of city for PhD exam. So we don't have enough time. So fast.
Okay, thank you very much then, Dr. Savaş, for your presentation. And we will move to the next presentation then by Dr. Sekban. And then it's the title is Examination of Welding Methods Used in Shipbuilding in Terms of harmful emission. It's very similar, it sounds, and we are looking forward to see it. And please do a bit brief introduction to yourself, if it's possible. Thank you.
Okay, thank you. Hello everyone, thank you for your participation. I am Dursun Murat Sekban from Karadeniz Technical University. I am Assistant Professor Doctor at Department of Marine Engineering Operations. Today I am going to talk about examination of welding method used in shipbuilding in terms of harmful emissions. Here you can see the content of my study. First, I will give some basic information about welding methods used extensively in shipbuilding and the importance of reducing harmful emissions. Next, I will talk about experimental procedure. Then I will discuss about results on changes in the amount of harmful emissions according to varying welding methods. And I will end up with basic conclusions of the study. As we know, shielded metal arc welding, gas metal arc welding, and submerged arc welding are most used in shipbuilding nowadays. During all these welding methods, the temperatures in the welding area rise to high levels. The metal melts and joining occur. On the other hand, it's known that significant amounts of the harmful emissions are released to the environment after this high temperature, and the melting occur in the welding. Considering the total weld seam length reaching thousands of meters during the building of commercial ships, it is possible to say the amount of emissions caused by welding during shipbuilding has increased significant levels. So it's extremely important to examine the effect of welding methods used in the shipbuilding on emission levels. In the study, the formulation accepted by the USA Environmental Protection Agency given below was used to calculate the weld emissions. In the formulation, E is the emission factor, A activity rate, EF pollutant emissions factor, and ER overall emission reduction efficiency in present. Emission factors for varying welding methods are selected from the literature and are shown in the table 1. Varying grams were calculated for changed welding methods, and emissions for a 50-meter weld seen with the values substituted in the formulation. Emissions are calculated separately according to weld methods that change according to the emission factors. The calculated emission factors for gram are shown in figure 1. As can be seen, 15.3 gram of chrome were realized after the gas metal arc welding, 8.1 gram after shielded metal arc welding, and 0.07 gram after submerged arc welding. After the calculation for cobalt, the highest emissions values were obtained after the shielded metal arc welding. It's 0.12, while the lowest emissions values were obtained during submerged arc welding as 0. As can be seen from the figure 3, after the calculation for mangan, the highest emission values were obtained after shielded metal arc welding, 48.3. The lowest emissions were achieved during submerged arc welding. It's 0.83 by a wide margin compared to the two other welding methods. After the calculations for nickel, it was determined that the highest emissions values occurred during shielded metal arc welding. It's 1.19, and the lowest values occurred during submerged arc welding. It's 0.11, as can be seen from the figure 4. Also, it was observed that while similar values were obtained for lead element during shielded metal arc welding and metal arc gas welding, it's 0.51 and 0.54 respectively. Lower emissions values were reached during submerged arc welding. It's 0.082, as can be seen figure 6. Okay, emissions and total emission values do the changing with values according to changing welding methods are given in table 2. As can be seen, the highest emission values in total occurred during shielded metal arc welding. On the other hand, it has been determined that the much lower emissions values occurred during submerged arc welding compared to the two other types of welding. On the other hand, as I said, those values are calculated for a 50 meter welding seam. For a commercial ship, much larger emissions will occur. We can say that. Conclusions in the study, the emission values that will occur if the 50 meters long welding seam is formed with 3 different welding methods which are used extensively in shipbuilding were calculated separately. The results obtained at the end of the study are summarized below. One, it was determined that highest emission values occurred in the shielded metal arc welding after 3 welding applications. 2, it has been determined that the lowest emissions among welding methods occurred during submerged arc welding with a large difference. And 3, among the emissions, it was determined that the highest values were obtained in the mangan and the lowest values in cobalt. Thank you for your attention. If you have any question or comment, I can take it. A speedy presentation.
Thank you very much, Dr. Sekman. That was another good one. It's 4 minutes for 58 seconds. Yes, yeah, as you said, please happy to take questions and comments for Dr. Sekman. Maybe you can leave the presentation on in case. I'm also checking if we have any question from channel.
I cannot hear now.
Do you hear my voice?
Okay, can you hear me now?
Sorry, I cannot hear now, but.
Duyabiliyor musunuz? Beni duyabiliyor musunuz?
Hocam sizi duyuyorum şu an. Ama Serkan hocamın sesi gitti sanki.
Okay, can you hear me now?
No, yes, I can hear now.
Okay, good, great. Just one of the last results, these 3 different methods, you compare the applicant, the worker or welder, let's say, are they the same? Like it's the comparisons. I really don't know how you measure, but the applicants did they apply the welding like same duration or same amount of thickness? What was the constant value? You keep it same. Like how do you compare? Like it can be this same panel, 2 pallet welded, but the thickness of maybe welding is constant. I mean, what was the constant value?
Values are calculated for the same thickness of the metal, same distance of the weld seam. Yeah.
Okay, that's very good. So this is repeatable, actually, what you are presenting.
Yeah, probably, yeah.
Okay. There might be some error, but it's still quite significant differences. So even there's error, I think you can clearly see who's the winner and who's the...
Yeah. Okay, thank you.
Okay. Of course, another method without using any melding material, I forgot the name of it. Was it something like with the rotational probe that join 2 parts? Maybe no emission at all. It would be the 4th method could be compared. That was another method. Could be interesting to see.
Actually, we can offer some different methods, welding methods, like solid state welding methods, like friction stir welding. Its emissions very low, very low than these welding methods. But you know, friction stir welding is not very in our sector. We not use our sector now as a commercial using. So, but yes, we have another welding methods we can offer, as I said, like friction stir welding. My PhD is study on was on friction stir welding of shipbuilding steels. I know the friction stir welding's emissions very low. Compared to these methods, but it's commercial using in our sector is now very low.
Yeah,
unfortunately.
do you think because of the ship generally has curved structure rather than flat panels?
Maybe yeah, maybe.
Another. Okay, maybe that's some. Sorry, please.
Sorry, maybe we can use it as you said, flat panels as firstly, because it's flat panels is very yeah, yani we can use as a, in the flat panels.
Yeah, that's something. Another reason the welders or the workers not accepting most of time the new methods. That's another thing is they need to. When the robots came, they really didn't want to use because they thought it will take their job. So there is lots of things like preparation before welding, montage, etc. There are lots of stuff, of course, going on, and new methods.
Also, finally, I can also say that advantages of emissions as well. Friction stir welding have another advantages. Like in my PhD studies, I saw that the friction stir welded steel's mechanical properties much higher than the gas metal arc welded or submerged arc welded shipbuilding steels mechanical properties, corrosion rates, strength, hardness, all of these mechanical properties are higher than the other welded shipbuilding steels in the welding area.
That's important, of course. Top of emotion, yeah, structure-wise. Like the Professor Alkan's ship, 89 knot ship is possibly heavily vibrating, so the welding might be not the best method. So this another thing, the correct friction, yeah, that kind of structural damage can occur when the ship is heavily vibrating. So welding is not the best way sometimes to join two methods. Yeah. Any other questions apart from my? Bit low volume.
I wanted to adjust my voice. I listened our presentations. I think my voice is coming a little noisy. Sorry about that. The Dr. Murat Sekban, has very interesting studies, as you discussed a few minutes ago. Very interesting welding methods he's dealing with. On the first day of our Congress, there was an NEC project called Resurgam. In the Resurgam, he is also concerned with these studies, the researchers in the Resurgam. I think for our local industry series, we should offer this solution for different applications. I don't know the details, but there are for the joining metals, joining different kind of metals, it is a big problem, and also the lifetime, the fatigue problem, and so on are important. About the emission, just a very short comment from the industrial high school. Why my field was metalworks, metallurgy or metalworks. We were using classical electrical welding. So the how do you say smoke and the gases, you know, making your voice very bad if you use I don't know masks on. The MSU you smell it for your respiratory system to so on. It is very dangerous. Yeah, welding is very important. Thank you for the presentation of Murat Sekman. There were, I think, 2 papers in our Congress on welding. Musun Saral also presented, I think. Yeah.
Yes. Already 1 paper, like 2 paper welding emission already presented.
Levent Bilgili and Sekban, sorry. Yeah, two papers. Thank you. No more questions. Thank you.
Thank you. Well, thank you, Dr. Sekman. And if there's no further question, we can move to the next paper. Just Professor Alkan explain the paper 60 will be recorded and uploaded as understood. And then, okay, it's still the case, isn't it? Then we can move to the...
thank you. The other author, industrial colleague is away, but okay. It is better to present together. It will be more efficient. No. So please keep it.
Definitely.
Sorry
it's
about
quite interesting. Yes, I'm sure we will. Yeah, but it will be in the system sometimes.
Yeah.
Okay, and we can move to the next paper. It's the paper by Dr. Kesoğlu and Dr. Akman and then Dr. Çınar. The title is Environmental Cost Benefits of Cold Ironing System in Green Container Ports for 2020-2030, and it's a case study in Turkey. And yes, the dear presenter, stage is yours, Dr. Kesoğlu. Thank you.
Hello, everyone. Can you hear me?
Yes.
Okay. Just a correction. Myself and Mr. Çınar is not does not have a PhD yet, but Mr. Akman has. So we are just have our master's degrees. I'm going to share a screen now, just a little bit delay. Okay. I think it's on, right? You can see it.
Yes, please.
Okay.
Yes.
My name is Mesutcan Köseoğlu. I'm a research assistant at Piraeus University Maritime Faculty. I completed my bachelor degree in maritime transportation and management engineering in Piraeus University, then completed my master's degree in Istanbul Technical University, maritime transportation engineering. Now I'm working on my second master's degree in industrial engineering in Galatasaray University. My study fields are green ports, smart shipping technologies, and ship routing optimization. Now I'm going to continue my presentation. Our study is called Environmental Cost and Benefit Analysis of Cold Ironing Systems in Green Container Ports for 2020-2030, a case study in Turkey. The contents of the presentation will be aim of the study. What are the green ports? Green ports in Turkey, cold ironing systems, methodology and materials we have used in this study, the case study, and the results and conclusion. The aim of this study was to find the answers to whether it is environmentally beneficial to invest in cold ironing systems for port management companies. The main focus has been researching the viability and feasibility of cold ironing systems in green ports with the environmental and financial perspective. The green ports are environmentally green ports are an environmental friendly and sustainable ports that meets the environmental requirements. In green ports, when policies are considered, practices should include factors such as environmental and natural life friendly approaches, keeping the pollution level at the lowest possible level, using renewable energy applications and recycling. And there is a connection between the environmental problems that ports face in order to become sustainable and criteria specified in the international literature and legislations. 10 most international green port criteria has been established as the air quality, waste management, energy consumption, noise, ship weights, relationship with residents, dredging, dust, port development, and water quality, as seen in the figure on the right. These criteria paved the way for low energy and water use, waste management, and air quality, as well as lowering cost and development of social relations, and the prestige of being a green and receiving investment from funds. Green ports in Turkey rely on green port policies that ensure the inclusion of sustainable practices in development and operations of ports with an organizational culture aimed at increasing environmental awareness. With spreading green culture, it extends to ports customers as well as the port employees. In Turkey, as seen in the figure, it is not a requirement to be included in the green port projects. On a voluntary basis by many leading ports in Turkey, green port projects are adopted with the idea that it is an element of prestige, a way of keeping up with the global developments, which also enables the spreading of greener approaches and environmental measures, as well as increase in such applications. Now, in the cold ironing systems defined as the practice of cooling down of the iron coal fired engines while ships were moored at berths in the past. Ships may utilize CI or cold ironing either from the ship to ship, such as military applications, or from shore to ship, while only shore to ship connections have environmental benefits. CI involves moored ships to shut down their generators and the use of clean energy provided by the shore supply unit to power main systems and to meet the power demand of all onboard operational facilities such as cargo equipment and accommodation parts. This technology enables moored ships to use shore power rather than them utilizing their onboard auxiliary engine generated power to reduce emissions at ports. Cold ironing is an initiative that will help the shipping industry contribute to this goal, and it will dramatically eliminate the noise from generators while at port. It will also reduce the different types of local emissions, and it will potentially reduce the operational cost because of the large-scale electricity generation is typically cheaper than running diesel generators. Operational diesel generators for ships to cover their electricity requirement has a large effect on air pollution. These generators or auxiliary engines of ships burn cheap, less pure, poor quality and low efficiency diesel fuel, resulting them to emit high amounts of air pollutants. Cold ironing systems consist of three main components, which are a shore-to-side electrical system, an infrastructure, a cable management system, and a ship-side electrical system. The shore-side electrical systems transmits power from high-voltage substations to connecting points near ships, which are distributed boxes at terminals to transform voltage levels, convert frequencies, switch between ships' power receiving systems in an uninterrupted manner. The cable management covers the cables and the facilities connecting the shore-side connecting points and the ship-bound power receiving facilities. The cable-connected facilities must meet the requirements of the quick connection and storage and be stored on ships, onboard ships, on the shore, or on barges when not used. The ship-side electrical system is an additional power receiving unit based on the original ship-bound power distribution system, including cable winches, transformers, and relevant management systems. The methodology we used is comprised of total cost calculations and total benefit calculations, and total costs has been calculated as the cost of infrastructure for cold ironing system, operational cost for ships at port and yearly maintenance cost, as well as environmental costs from cold ironing system and ships at port, and the price of electricity received from the city grid. The main approach for benefits is establishing the calculations from environmental cost of the unused auxiliary engines and the price of electricity sold to the ships when using cold ironing systems by port. This is the analysis steps which showcases the process of calculating costs and benefits. For the total monetary costs, they are established as the financial annuities of port operations for each ship, the cost of initial investment for cold ironing, annuities of maintenance costs, and cost of receiving electricity from the city grid for each ship. Price of electricity from the source has been established as the industrial usage on medium voltage according to the most recent pricing from the Republic of Turkey Energy Market Regulatory Authority, or in Turkish EPDK. Environmental cost calculation has been established as the product of the amount of electricity required per ship and the product of emission factors and external costs of each ship, each pollutant at port, and emission source from the ship, emission source from the boiler of the ship. This is because while with cold ironing, only the vessel boilers remain switched on at port. The reasoning for boilers to remain operational at port is that it is much more beneficial in consideration of fuel consumption and emission for smaller berth periods than shutting it off and then switching it on when the ship leaves the berth. For environmental benefit assessment, SOx, NOx, and CO2 pollutants reduction achieved by utilization of cold ironing system has been calculated with the external cost and emission factors for each pollutant. When the cold ironing system is utilized, ships do not need the power source from the auxiliary engines to run the operations or regular life on board at berth. And the total environment cost from ship's auxiliary engines of a pollutant released from the ship using low sulfur has been included. The total financial benefit is calculated with the product of the amount of energy given to the ship and the price of that energy. The cost-benefit analysis case study for this container port has been carried out to investigate the feasibility of the cold ironing system in container ports with an environmental focus for the years between 2020 and 2030. The data for ships and time spent at port has been gathered from a container port in Turkey, and 1,048 viable data out of 1,060 container ships has been extracted from the collective data, roughly representing the number of ships the port in this case study holds over a year. The cost of infrastructure, maintenance, and operational cost has been calculated in consideration of the previous recent studies that have been carried out on cold ironing feasibility. And the port facility chosen for this case study provide berthing for up to 4 ships depending on the ship length. For the maximum evaluation number of berths has been set as 4. And since it is aimed to provide cold ironing to all ships during their cargo operations and considering the cold ironing system to be applied on 4 berths at the same time, also maximizes the total monetary and environmental costs. In these figures, it shows the results of the data, or the summary of the data we have collected. The categorization of the ships has been conducted as ship's length, container capacity in TEU, and the time spent at berth. These are the average times on the cursor. These are the average time spent at berth per ship category, and they are categorized as the container capacity and the yearly percentage of the case ports hosted ships. In the results, when the total benefits and the total costs are compared in 10 years, the benefit to cost ratio shows, although the initial investment cost and the annuities are relatively expensive for cold ironing system, the effect of the ship Ships not using their auxiliary engines provides an exceptional benefit from an environmental perspective. In the year's end, there's a 47.2% benefit, and in 10 years, there's a 46.1% benefit, including environmental and financial benefits. So this observation is emphasized with the benefit-to-cost ratio of environmental costs and environmental benefits, resulting in 38.2% for 10 years and further proved beneficial with the total benefit-to-cost ratio for the current year's end with the 47.5%. Financially, cold ironing systems are not observably beneficial for the initial year, but calculated to be beneficial in a beneficial tendency for the 10 years period, reaching nearly 39.7% in profits. This is made with the assumption of the selling price, while for profiting purposes, port management may increase the price in consideration of the costs depending on the region. By multiplying the emission factors and the annual fuel consumption, the effect of cold ironing operation on the total CO2 emissions is presented in the figure on the right. Accordingly, cold ironing provides a 62.8% decrease in annual carbon dioxide emission at the ports, since ships are not using their auxiliary engines, and this results in correlation with the environmental benefit-to-cost ratio, showcasing that cold ironing systems are a powerful application for the greening of ports and green port projects. Now, for completing this study's presentation, I have a couple of remarks, 5 to be exact. And the main purpose of the sustainability in ports is to increase the financial performance of ports, reduce carbon dioxide emissions, provide greener service, protect the environment, and consume less and act economically for the future of the world. Green terminals are responsible for being in coordination with their local areas, promoting high efficiency, increasing collective trade, improving the overall framework, and connecting with the community. The cold ironing system has been proven to be a promising technique that provides many environmental and social benefits by reducing air pollution from ships moored in ports. For a local air quality perspective, a ship using cold ironing is preferably to one using auxiliary engines to meet the requirement of power on board operations at berths. From the financial perspective, although the profitability for the initial year is calculated to be not beneficial, in 10 years in the long run, the investment cost and annual costs, as well as the price of receiving electricity from the source has seen to be beneficial with the estimated energy selling price to the ship. This benefit can be increased more with the greener approaches other than cold ironing, such as ports generating their own electricity and cutting up some of the energy received from the city grid or the local grid and giving their own energy, their own produced energy to the ships and increasing their profitability. The cold ironing systems are projected to be a great option for both enabling environmentally beneficial industry and financial profitability in the long investment period in Turkey. Thank you for listening.
Thank you, Mr. Kasaoğlu.
Thank you.
I'm sure it will be doctor soon. And
hopefully.
For the very important, very good topic and the study presentation. Stage is open for the questions and comments. While the other participants are thinking, that cold ironing particularly was important, I believe, during the still COVID time, especially a cruise vessel couldn't travel. They had to keep at berth. So they had to just keep running the system. And then that was a bit question whether it's good, like they are always in the city. So the emission increased, but maybe cold ironing helped them to a bit reduce the emission, where this ports are close to the living areas. During the COVID, many ships couldn't do their business as usual, so they had to keep at berth and in the port. Maybe would you include something like, maybe you can comment or on this during COVID, is there such a measurement has been done? How much the emission change during this pandemic period? Because the ship couldn't really travel. I don't know, maybe containers was exceptional, but
I mean, I believe in the first couple of months of the COVID, because of the shutting down of the factories, the container industry has been hit, or generally the maritime industry has been hit hard. But later on, as the delivery or shippings has increased and the factories opened with the precautions, since the from door-to-door delivery systems, or such as big companies such as Amazon, or there are a couple of other initiatives have increased the effectiveness or the need for the maritime industry, specifically for container shipping, and that may have caused an increase in emission, but the port times of container ships are limited, as we all know, and because of the fast operations. But the data, such data is not in my reach, but I haven't been able to obtain such data. As we may all know, obtaining data in maritime industry is very hard, and we do what we can with what we have. But on a comment on the cruise shipping, the cold ironing system has been utilized in Europe or in the United States or other developed countries as a means of supplying energy to the cruise ships while they're at board, because they consume tremendous amount of energy on their time at board or during their travels, and which also resulting in high emissions in cruise vacation areas. Kuşadası is an example for that. There's a cruise shipping port, I believe, and they have tried cold ironing systems, but in Turkey, honestly, cold ironing systems are not really regulated correctly, because I believe there is no cold ironing application that continuing cold ironing application. There are some feasibility works for Marport that Istanbul Technical University, I believe, have carried out in 2020 for Marport, but they also found out that the cold ironing is beneficial. But when I met them and when I met other ports HSAQ departments, they informed me that there's a problem with taxing of the energy, because since the ports are basically are the areas that basically they are international areas, giving energy from ports from Turkey to a ship, let's say with a Marshall flag, can be considered as selling electricity to internationally selling electricity, which also resulting in import-export taxes, high import-export taxes. So there has to be a regulation on that manner if the feasibility of such application will be carried out, or the regulation, the cold ironing systems should be included in the green ports criteria of Turkey. The standards in the TSA, TSE, and should include such regulation on that manner, because the green port certificates are given by the TSE and the Minister of Infrastructure, or Minister of Environment, sorry.
Okay, very good. Any comments from this question of the participants? Supposed to check YouTube as well.
Yeah. Yes, I can say maybe 2 sentences. Thank you very much for your interesting and well-prepared presentation, I say. Cold ironing is an alternative to decrease emissions for marine vehicles. It is interesting. There are studies, yeah, with the economic perspective of cold ironing in different ports. Yeah, we realistically define the emission, how the source of the cold ironing. If I in Tuzla, if I give cold ironing services to the ships, the electricity we obtained consists some emission of the source, the electricity production plant, yeah, of course. So cold iron will remain always is a topic, and there will be a competition on that. You should produce electricity with less emission. So cold ironing, it will force also the price, I think. Also cold ironing monetary unit per kilowatt hour, I think. I superficially have information on that. Very interesting study. Thank you.
Thank you.
Yeah, that's Istanbul port is going to open. Maybe you can establish a measurement device there. How much, and I'm sure Istanbul governor will be interested in how much it will impact the that region, the emission, because the new port supposed to attract the big cruise ships, and you have no emission with cold ironing. Maybe they would like to hear this one and practical work. And another thing is there's a study 2015 by Balini and Rozzo about the 60% cruise ship vessel reduce the emission. Apart from container, this cold ironing is, I think, is very important, like the port cities like Istanbul, Tekirdağ, kind of Kuşadası. I think that's very important. Thank you very much.
Thank you for your insight.
I think, well, we need to move to next one. It's another interesting topic, Dr. Ölmez, and then the title is Win-Win or Win-Lose Situation Assessment of Ship Recycling Sector of Turkey in terms of Green Marine Industry Approach. And checking, our presenter hasn't arrived yet. What we can do, maybe we can move to, if I'm not mistaken, he's not in the participant list. Dr. Hasan Ölmez is not here, yes? Okay, so if he join later, we can ask him to present as a last paper. In the meantime, I wanted to switch Dr. Nalan Error and then Dr. Kamer and Dr. Çaylak. The title of their paper is A Look Through Autonomous Vessel. If they are ready, I think it's better you present. And then please give a brief introduction about yourself. Thank you very much.
Thank you. First of all, we are very happy being in this organization. I shall share my screen and then okay. Are you seeing the whole page?
Yes, we are seeing your presentation.
Okay, thank you. I'm Nalan Erol, working in Uzmar R&D department as a project leader, and today we prepared a presentation about autonomous vessels with my colleagues, Mr. Gökhan Kamer, our design manager, and Mr. Emre Çaylak, our business development executive. we will try to give brief information about these autonomous vessels. Here is the content of our presentation. We will give the definition of autonomy and why it is needed, and we will speak about the levels of autonomy, and then we will briefly give information about the current projects and the future projects, and then we will be speaking about the design part of these autonomous vessels, and mainly the software part, the technology behind and how it works. And then we will be giving information about the challenges, and then we will speak about our own autonomous project. Let's start with the ship autonomy. Ship automation systems permit individually and geographically diverse components to work together so that a plant can be monitored and controlled remotely. Here we would like to give the difference in unmanned and autonomous ships. In unmanned ships, it can be remote control. It is without the physical presence of a person on board. But when it is autonomous, it acts independently of people. These are the autonomy levels according to IMO. There are 4 degrees. Degree 1 is already reached. Ship with automated processes and decision support, seafarers are on board. When it comes to degree 2, it is remotely controlled ship with seafarers on board. When it is degree 3, it is again remotely controlled ship, but without seafarers on board. And when it is fully autonomous, it is degree 4. Ship is able to navigate itself and making decisions itself. So why autonomy? Why do we work on these projects? Because it has many positive effects, such as reduced or eliminated need for human control, so decreasing the human errors. It provides longer duration performance, and there is improved reliability compared to remotely controlled unmanned vessels. There is the controllability and deployability enhancements. There is also reduced personnel costs. It enables extended operational capabilities. There is the reduced risk of piracy for both the crew members and the cargo. Increased available space, so more cargo place. And there are reduced design constraints, not having people on board, and removed need for a traditional navigation bridge. So it also has many design advantages too. Here is an image of Rolls-Royce Marine, how it is going to be, how we will reach the autonomous vessels. By the year 2025, it is thought that we will be seeing remote-controlled unmanned coastal vessels. And 10 years later, we will be seeing remote-controlled unmanned ocean-going ships. And by the year 2035, we will be seeing autonomous unmanned ocean-going ships. In current situation, there are both studies about the legacy part of it, the rules part of it, and the technical part of it. Here is the Maritime Safety Committee's studies on SOLAS, Kongre, load lines, training of seafarers, tonnage measurement, and special trade passenger ship instruments. And also there are very big conjoint projects of Kongsberg, the NVGL, Rolls-Royce, and EU. And on the other hand, there is a Japanese consortium working on autonomous boats, and Samsung Heavy Industries, Hyundai Heavy Industries are working on it. There is the CAS project. And there is an interesting point that up to now, there are 3,000 patents only in China, which are related to autonomous shipping technologies. What is changing? What is changing in a ship when it becomes autonomous? This is mostly related with the naval architecture part. For example, in hull structure, when a boat becomes autonomous, there will be closed structure, external access for maintenance and repair, and there will be streamlined exterior. So wind resistance will be reduced, and prevention of piracy for crew and cargo will be enabled. When it comes to deckhouse, there might not be a deckhouse even. without accommodation for crew, no stairs and doors, no sanitary system, no galley and laundry. So there will be ship lightweight reduction. So it will be possible to load more cargo, and there will be a reduction of ballast due to reduced weight. In machinery, there will be no HVAC and life-sustaining systems. There will be small main and auxiliary engines and reduced electrical fuel consumption. We will see. When it comes to propulsion systems, mostly there will be electric hybrid propulsion systems, electric propulsors, DC grid system. So efficient electric power and reduced electrical consumption will be in use, and the efficient control of the equipment will be seen. When it comes to equipment-wise, there will be more hardware, software equipment on board, such as IR cameras, LiDAR, radar, high-resolution sonars, microphones, wind and pressure sensors, homogeneous and heterogeneous redundancy. And it will make us consider installation and integration of these all equipment, and there will be potential requirement for remote maintenance and inspection. When it comes to hull outfitting, there will be a need for fully or semi-automatic cargo handling and mooring systems, and there will be no life-saving equipment. So boarding crew for cargo handling and port calls, we will be seeing decrease of lighting and ventilation, modified dockside infrastructure, and electrical and fuel savings. So actually there is a lot of change when we look at the subject and design-wise. How is this achieved? How a boat becomes autonomous? What it has to do and how? There are main 4 subtasks. These are object detection, object identification and recognition of the detected object, and then object localization and movement prediction. These are all done by GPS, radar, LiDAR, sonar, odometry, and inertial measurement units. Here is a DMVGL's prepared summary of an autonomous system working. First of all, we have our radars, IS camera, LiDAR, other sensors, which is in the condition detection part. They all go under sensor fusion and cross verification, and the outcome is the detection of the object. Then comes the condition analysis. In a world model, the object is classified and then its situation is analyzed. And it comes to the action planning, collision and grounding, avoidance, and moving on. And there is the action control part, which is done by the control system, checking if everything is going well. And also, sorry, just to turn back, this sensor fusion and object detection, classification, and the action planning system are all done by a familiar word that we hear a lot, algorithm. What is an algorithm? Algorithm is a decision-making system that allows us to imitate a captain's brain. Let us briefly say, we hear there are lots of algorithms, as you might see in the image, from 1999 up to date, and more going on, starting with generic algorithm, A-star, velocity obstacles. There are machine learning methods, deep learning methods. There are neural network, as in reactive methods. How this algorithm works? Let me show by an example. Here is A-star algorithm, which is used in shipbuilding, in ships a lot. It's very simple, actually. It depends on avoiding obstacles, as you might see as a gray color here, and choosing the shortest path. I don't know if you could see my cursor, but mouse. When it is moving to the target of point 1 to 1, the A-star algorithm chooses the shortest path. It doesn't go from 4-2 to 4-3, but instead it goes to 3-3. And then it doesn't go to 3-2, but it goes to 2-2. 2.2, this square. So this is basically how a simple algorithm works when it comes to decision making. Also, as I mentioned a little while ago, IMO said there are 4 degrees of autonomy levels and degree 1 is already reached. In order to reach the other 3 levels, we need to work on the issues I will mention now, such as the regulatory framework, liability, cybersecurity, safety and navigation, reliability and maintenance, connectivity, and piracy. This is the general part of it. And there is another part of it when it comes to softwares and hardwares that are needed in autonomous shipping, autonomous ships. It is the real-time response, computational complexity, black box behavior, accuracy and reliability, safety, security, and IE and ethics and IE. IE is artificial intelligence, sorry. So when it comes to UZMAR's project, I'm coming to the end of my presentation, small by small. We are a group company. We have our pilotage company, we have a shipyard, and we have our technologies part, and we have delivered more than 150 vessels. These are our references. And we have our own R&D department now working on several projects, which is one of them is our ERP system, which is a first step of our digital shipyard. Another is O2's online situation control and plant maintenance system. We are also using VR for our design activities. And also we have a Horizon project, which has a instability helping system on board. When it comes to UZMAR's autonomous project, it will look like this somehow. It will be capable of route mapping, decision making, data transfer, and call rec-based collision avoidance. Let me summarize its capabilities here in a table. It will be a small boat working in a bay and giving information, supplying information to our tugboats for easy maneuvering and easy pilotage work. The system will take into account the sea readiness check, voyage plan, weather check, path planning, unmooring, mooring, object detection and tracking, control and monitoring, alarming and decision making, collision avoidance, emergency response, and failure diagnosis. We are at the very beginning of the project, so I'm not able to give any more information about it, such as the main dimensions or the propulsion system, but soon we will be revealing those too. Thank you for listening. These are our references, and we would like to finish our presentation by saying the best way to predict the future is to create it. Thank you very much.
Thank you very much, Dr. Erol. Very interesting presentation, exciting project. And it's nice to see industry in the presentation as well, like the conference. In the end, we are all trying to do something that's really 3D structure and futuristic. Any question to Dr. Erol?
Yes, I have a question to Nalan Erol. Nalan Erol. The topic is very interesting, multidisciplinary. In the world, of course, there are, I cannot find the adjective about it. There is a Türkçe'de. Very intensive works they are carrying out. As UZMAR, I think your team will further develop this project with the collaboration sorry, with the collaboration of universities, including Sarkans University and other. We are all ready. I think you will accomplish a successful project. So it's just a comment.
Thank you very much.
Thank you for your nice presentation. Okay.
Actually, I have a question. What do you think? What what the industry needs from university to achieve this technology? Always we are getting comment that maybe graduates are not ready for this. Do you think? Oh,
Sorry, I couldn't hear your voice.
I noticed
you
my
said?
internet is not good.
You asked what we need
industry,
from
universities. Yeah, do you think we need more new programs to teach students this kind of technology, autonomous shipping, the ship systems, rather than classic naval architecture, marine engineering? Should we bring new topics to the, like the team you have? Are they mainly from naval architecture, marine engineering background, or they are electricians?
Okay, I think I understand your question. In our company, we have a separate technologies group, which are computer engineers and electronical engineers. So in the software part, and we here, Mr. Emre and Mr. Gökhan, we are all naval architects. And actually, we are working closely with the universities, with the electrical department of the universities. They are very open to projects, these kind of projects. But as you mentioned, it might be better to find more ways to combine the industry studies with the university studies. I may say by myself, it's far more better than now when I started working. And I would like to ask if Mr. Gökhan or Mr. Emre would like to add anything on this.
Hi, everybody. Let me add some words about that. Of course, this is a very multidisciplinary problem, and we are facing a lot of challenges as we try to describe in our presentation. And universities has a very important role, and we have very close relationship with the Maritime Faculty of Istanbul Technical University and all other departments from different universities, like Ms. Nalan said, electronic departments, software departments, and not only universities, also we are trying to create a network which we would like to implement the existing technologies in other industries like automobile industry, aviation industry, and so on. So this is not only related to naval architecture. This is very wide range of multidisciplinary, and it is very new technology actually, because when you look at the development of the artificial intelligence will be the core of this development, and this is very new in all the industry. So we need to be very close cooperation with wide range of stakeholders from the industry, institutes, research institutes, and universities as well. So we would like to be the coordinator and the front runner of the project, but we need a lot of support from universities. Also, I can maybe give you an example. There are also student teams in Istanbul Technical University. There are some international competitions for developing this artificial intelligence. We are supporting them. We are having a lot of meetings with them, and I think they will realize this. Not our generation. We are a young team, very young team, in the UZMA, in the R&D department, but this is not our generation's job. I think these young generations in universities, they are students now, and they will realize these autonomous vessels. We believe them very much.
Well, true, you are showing the future, and definitely the universities need industrial advisor like you, and they can actually choose their projects, and even the teaching program can change. Transport of Minister in UK announced what you are saying, and they are giving lots of funding to industry and the universities to change their structure. And this is actually very important, national, international wise. And definitely this step has to be done. And I congratulate Uzmar for doing this. It's very important because there's no guidelines and everybody will look at this example, what you are doing. And it will be more important in the very near future. Then emission is important, human factor is important, decision making. Definitely everything is smart technologies, and the ship has to be smart, and our students has to be smart. That's great to hear.
Thank you very much. We are very much excited, and we are glad that you are also excited.
Yeah, definitely. I will be one of the person following.
Thanks a lot.
Further questions? I'm trying to check.
If Mr. Kamal asks, I'm waiting for him. If I will add something, but maybe Kamal will say something. I don't know.
Thank you for this presentation to Ms. Nalan, and also for all the participants to this organization. It is good for us to be here and explain ourselves and to make the decision maker on these roles for the naval industry in Turkey. We, as a Uzmar shipyard, we believe that the autonomy will lead the future of this cargo handling, cargo transportation, and the many sections in the Navy, and also the maritime sections. So that's all our research and development department and all the organization will be prepared to this stage of this technology at this stage. As Nalan and Emre said, we have many good cooperation between the subcontractors, technology introducers, and also the universities and the class societies. You know, this technology is not related with the technologies, and also it is related with the legacies and rules and requirements of this maritime industry. We have a good contact with the class societies, especially in Turkey with the Turkish Lloyd and also the Breveritas. And also we have attended many autonomous tenders as a Uzmar shipyard all over the world between the different kind of the societies and the tenders owners. So as we said, if we have the good position in this role of the autonomy of the vessels inside the shipbuilding sections and all over the world, then we will be happy, and it will be good for all industrial stakeholders, as universities, as suppliers, as class societies, as a Turkey. It will be at the end of the game good for all of us. We believe that. Thank you.
I will, with your permission, dear Chairman, I will add a few words. Thank you. Very interesting subject. Of course, it is an RTD project, multidisciplinary, and the collaboration is concerned with the universities, with the experts, class societies, so on. I should say very interesting conversion or attitude, I can say, of the universities. Now the students, Karadeniz Technical University, our university, my university, Yıldız Technical University, or ITU, Bursa, Bandırma, we are together now in the spring. There are colleagues from different universities, including Turkish Naval Academy of National Defense University. We are all together. We are like a cluster, research cluster of the universities with our technology transfer offices and technoparks. Now more entrepreneurship is active at the universities. So I know very well there are what we call it RTD divisions, authorized RTD divisions of the shipyards and other ship industry companies, authorized by the Ministry of Industry. More collaboration is needed to prepare, let's say, paper for this conference, for papers or other publications for other things, including journals. There were some papers arrived to this conference. I tried to connect and suggested some sections, some arrangements, so more collaboration is needed, briefly saying. More collaboration. We should express ourselves to abroad. This conference also aims it from Uzmar, from universities, from other industry students, from Croatia, from Britain, all. There will be, I hope there will be another special workshop or any symposium on these issues, because there is a big competition in the world. We are together always, I say this.
We are also open to any type of collaboration, of course.
Yeah.
We are passionate about maritime people. Although we are naval architects, we are in a shipping company, and it's as a part of a maritime company, we are passionate about our business. So all these technological developments, and we are, as I said before, we are very excited to be a part of this technological development, and hope to collaborate with all not only universities, other companies, other shipyards. We are open to work together.
And the universities try to send students to the industry for short-term visits, for their project, for their completion project, or as training, compulsory training. More interactions with the Technopark. So there are more interactions.
Yeah, we will try our best, and I can also announce here that our board's decision is to create Turkey's first autonomous shipping laboratory. So we would like to. It is not definitely defined yet, but the target is over there, and Uzmar is willing to create the Turkey's first autonomous research center. We are discussing with the universities and other software developers, and hope we will be taking a position.
For the prototype operation, I think Sapanca Lake will be very interesting for you, or something similar.
Yeah. For the prototype, yes, but that will be a research laboratory, not only for the vessel itself. We will be doing simulations and training of the maritime students for the future autonomous shipping. So that's a huge project. We will be sharing the details with the industry very soon.
What a nice, çok güzel.
That's great news. Thank you.
Great
We all need data.
Sorry, I think we take a lot of time.
No, that's actually we are perfectly on time, I believe, because also we don't have two papers, so there's no problem. I'm just checking. I think it's better to close the session. Hard to say because it's quite interesting, but thank you very much for Dr. Erol's presentation and the Uzmar team, Mr. Kamera and Mr. Çaylak, for their great contribution and Thank you for the other presenters. And then we are closing this section. There are more coming, and then see you in the future. Have a great afternoon. Bye-bye.
Thank you.
Bye bye.
Bye-bye.